guys know. All right. So, what are we reading today? What's the title? By? So, what does this represent? What is that? The title, right? Okay, and what is the name underneath? The author. Okay? Now, on the back, what does this represent? A summary. Very good. What is this? Very good. What is this? The cover. What is this? The back. Yeah, the back. Very good. And what's all this? The meat. Very good. This is the skin. This is the meat. This is the information that the book held. Oh, surprises. And we're going to discover.
How Bob studies.
All right, ready?
Like,
I don't know that name.
I
don't. How do you know?
Gilbert Bashry. Yeah.
Gilbert Bashry.
Yeah.
It sounds right. Gilbert Bashry first became interested in science in 3rd grade when he started reading science fiction stories. His dad bought him a small telescope. What is a telescope? You can tell me, Josiah. It's just a really close-up what?
Eyeball.
It's like you could say something very close to.
Very good. No, that's right. It's to really look closely up at the stars in the sky at night. Very good.
It's just a bigger,
Like a big, what's the thing like a...
Monocle.
There you go. Very good. That's the word that I was looking for. Good job. What?
You know, as a glass that they use for the cars, like the little mirrors, they use that for the telescope.
Yeah. Good job. That's good information.
I know you're welcome.
You didn't even.
All right, and he used it to watch the stars from his bedroom window at night. Okay. Bashry. What'd you say? Bashry says, I remember Orion would go by in the winter. What did we learn in our constellations? Where Orion is? Where? Where? Huh? Yes. Today, Bashry is an astronomer. What's an astronomer? Jeremiah.
A scientist that studies stars.
Very good. A scientist and investigates stars. Very good. Bashry asks questions like, how do stars form? What are the smallest stars like? How do stars change over time? Now, what do these numbers on the bottom represent?
The page number.
You didn't raise your hand. It is called, yes. Yes. Now, what are these called? Yeah, that's what he looks like. Doesn't he look handsome? Look how cute he is. He's so cute.
I dare you to say not pretty. I dare you to say pretty.
He's purty. Nice. What?
That's my boy back there when we used to play basketball. He tried to dunk, he broke it.
I don't know what's going on back there, but stop.
Remember Miss Kennedy?
What?
That was my boy back there. We used to play basketball and he had dunked and he broke it.
Understood.
That's why he retired.
This is Gilbert as an astronomer. That's a picture of him now. Now, I'm going to start at the top, okay? Stars are not easy to investigate because they are so far away. The sun is close enough that we can see spots, flares, and other features. All the other stars, however, are much too far away to see clearly, even though the most powerful telescopes can't answer his question. Can't answer whose question?
Gilbert.
I was just making sure you were listening. What?
What is that that's in his hand? Is that a telescope?
That's a big, big telescope. Yes.
It
It is a big telescope. Yes.
I thought that was a drum.
No,
drone.
Even though the most powerful telescopes cannot answer his question by looking at them. To answer his question, Bart, I can't say his name.
Lars Bashry.
We're gonna call him Bob.
Yeah,
okay?
no.
Bob needs data, measurements, and observations gathered in different ways. What is data? Natalia? Very good, very good. Thank you for listening. From Earth, a star may look like just a pinpoint of light. But that light gives Bob the data he needs to figure out what the star is like. Based on the light coming from a star, Bob can tell how big the star is. How or what is it made of? How hot is it? How old is it? And more. He says investigating stars is like
Detective work.
I can't read today, obviously. Detective work. You don't have criminal in the room, but you have clues about what happened.
Kind of like
Kind of like a what?
the game of Clue.
Yeah.
There's a murder and then they
Murder mystery.
You have
and
to
then they
figure it
figure
all
out
out.
who did it.
Yeah.
Figure out who did it.
Does anybody else want to read?
Yes, I would love to read.
I would love to read.
Okay. Jeremiah, you can read.
One of the most interesting questions about Bob has helped answer is, do other stars besides the sun have planets orbiting them?
Say it again. You said the last sentence was?
Do other stars besides the sun have planets orbiting them?
Do other stars besides the sun have planets orbiting them? Who can answer that question? Ava. No, answer the question.
The other stuff besides the planet that has orbited them
What's she talking about?
What?
Yes, Trinity, answer the question.
I think Earth is getting orbited around the moon.
Yeah. Well, the moon's orbiting around this Earth.
I got
Yes.
it.
Now.
Can I read?
No, Ava's gonna read the next part. Go, Ava.
Many scientists work together to investigate this question. Some of the scientists were experts on planets. Others were experts on light and telescopes. Bob. It won't be that loud.
Don't worry about it. Go.
Bob and some other astronomers on the team were the experts on stars.
Very good. Very good. Dom, go.
The question of whether planets orbit
You gotta speak a little louder.
is difficult to answer. The stars are extremely far away. You can only see them at all because they are so huge and bright. Planets are small and dim compared to stars, so it would be impossible to see a planet orbiting distant stars. This was a question that could only be answered by data, lots of data.
Very good. Who can read that? The little 2 lines underneath the picture. Layla, read those 2 lines on page 5. Underneath the picture.
Can I just create this picture visualizing what the planets orbiting distant stars look like?
Very good. How many pages do we have total, y'all?
16.
How many?
16.
Okay, and what is this word called? That's very bad.
Glossary.
Okay, and what is each word bolded? Why?
The definition.
What?
The definition.
No. What is each word? What is?
It's
Each word is bolded, and then what is beside it? The definition, like what you said. Yes, very good. Now, you want to keep going?
Yes.
No.
Yes.
No.
Yes. Yes.
Therefore, Bob and the other scientists knew they would have to observe the same stars for a long time without interruptions. To do that, they had to send a telescope up into space.
Where are you at?
Hey, you're supposed to be on page 6.
Oh, my bad. I'm on page 8. I was on. See, you should figure it out. I'm sorry. Okay, the team of scientists thought carefully about what data they would need in order to detect planets orbiting can't speak today. Distant stars. As planets go around our sun, they sometimes get between Earth and the sun. When a planet gets between Earth and the sun, the planet blocks a little bit of the sun's light from reaching Earth. Is that correct?
Yes.
Yes, because why?
Because
Solar.
because the planet that is between Earth and the sun is
Like what? What planet is between us and Earth?
Mars.
Mars. Very good. Now, the sun looks a tiny bit dimmer as the planet goes past. This changes in brightness is tiny, but it's enough for a very accurate tool to measure. Does that make sense?
Yeah.
The scientists thought the same thing would happen as planets orbit distant stars. If a star has a planet orbiting it, that planet might sometimes get between the star and Earth, blocking a tiny bit of the star's light. The scientists realized that they could use data about the brightness of stars to figure out whether some of these stars have the planets orbiting them. Does that make sense?
Yes.
Alrighty. Braylon, you may read. Because you're so anxious to read.
So I'll read the whole thing.
Sure, if you can read the first 2 lines, and then somebody else you can pass it on to the next one.
The team of scientists knew that the changes in brightness would be very tiny, so they would need extremely accurate measurements. They also knew that they would need to observe the same star over a long period of time.
Very good. Dylan. Seeing the light of a star get dimmer just once wouldn't give them enough data to tell whether the change was caused by a planet or something else. You want to continue on that? Because I'm not going to wait. Go.
Can I?
Natalia, read.
They were data showing a pattern of the light getting dimmer over and over again as the planet went around and around, crossing in front of the star again and again.
They came up with a plan to record data and organize it into graphs showing the brightness of each star at many points in time. All right. I already started reading that, which is basically what this one is about is that Bob and other scientists knew that they would have to observe same stars for a long time without interruptions. To do that, they had to send a telescope out into space. Why? Why? Huh?
So they can get closer and look
Hold
at it.
on. Grayson, go.
They send it into space so they can get more information on the stars closer.
It says Earth spins, so we have daylight and nighttime. On Earth, telescopes can only observe stars beside the sun in the nighttime. Also, on Earth, the sky is sometimes cloudy. Even on a clear night, the air itself can change the way a star looks, right? Our sky has lots of clouds. It has dusk. It has, it's not as clear than in space.
Actually, in space it's dirtier because of the meteorites.
What?
In space it's dirtier because of the meteorites.
Yeah. In space, there is no daytime and nighttime. There is no clouds and there is no air. By sending a telescope out into space, space scientists would be able to take very precious and precise brightness measurements for the same stars for years without interruptions. Cool?
Cool.
I think that's pretty cool.
Cool.
Hey, what's the name of the telescope that they called it? What? Kepler. Very good. Who asked me to read? Nico, you can read page. Actually, we're gonna skip 9 and go to 10.
No.
Skip 9 and go to 10.
However, the scientists knew that there would be challenges. Just because a star gets dimmer for a while does not mean that there must be a planet causing it. There are other things that can cause the light from a star to appear dimmer. The surface of a star is not all the same brightness. As Bob describes it, all of the energy that's coming up out of a star makes the surface boil. Bright flares burst from the surface of a star, and there can also be dark spots on a star's surface. These dark spots are known as sunspots. For many years, scientists have observed sunspots on the surface of our sun. By observing sunspots, scientists discovered that the sun actually spins. They saw the spots crossing the surface of the sun, disappearing and then coming back around the other side. Sunspots don't last forever. They appear and disappear over time. Using data from starlight, Bob and other astronomers have determined that other stars also spin and have a sunspot. These sunspots can cause the light from a star to appear dimmer at times.
Very good.
Like the sun spins.
Nika, read the descriptions underneath the pictures.
This photo shows sunspots, dark spots on the surface of the sun. Other stars also have sunspots. This image compares the size of a sunspot to the size of Earth.
What?
Sunspots can be bigger than planets.
Do y'all see how big just that one tiny little sliver?
Yes,
Yeah, I know. Hold on.
Oh,
Do you see how big it is?
yeah.
That's insane.
The one at the very end, the biggest one, looks like it could swallow Earth.
Okay, so right here, there's a
You
graph.
know what I mean?
This is the graph that they have seen. Listen, this is a graph that they have recorded with the telescope. This right here, other astronomers have used Kepler data to find out about all kinds of stars. So it's not just our sun, which is what?
A star.
The only what? Is the only star in our. Very good. Now, Bob has his own desk. Look at that. Works at a desk on Earth, but in his mind he travels in the stars every day. Isn't that fun?
Whoa.
Oh, Bob has his own desk. That's crazy.
Oh, look how hot the sun is.
All right.